the last lesson we focused on was the scientific method and how it helps us to actually design and run an experiment. And we talked specifically about a controlled experiment and the certain steps throughout that. And the last thing we talked about was how after collecting data, the last thing we want to do is come up with a model that represents the relationship between variables. And one of the main models that we are going to use is a graph. Okay, it's a graphical representation of a relationship. So this lesson today is going to focus on graphs and how I want you to go about graphing things to make sure that we see the relationship in a proper way. So this lesson is a first in a set of lessons that's going to be focused on understanding relationships from graphs and also using graphs to develop a mathematical relationship or a mathematical model. All right, so after today, you should be able to do the first of these two objectives, which is to understand the rules of graphing and to be able to graph any given set of data. Now, with the first couple of graphs you're going to do, I'm going to ask you to graph them by hand, just so you get used to these 7 rules, and then we'll introduce a program that'll help us to graph these things. Now in math class, you've probably seen multiple graphs that you could use. You've probably familiar with a bar graph, pie charts. Those graphs are fine, but really when we're looking at data, we want to really see a relationship that's more of a mathematical nature. So what we are really going to look at in terms of graphs is like an XY scatter plot or when we're actually graphing points. Okay, and some of the graphs we actually will introduce throughout this year is also a 3D representation of a graph. It's simply taking these two-dimensional plots and graphing them in 3-dimensional, which helps us sometimes to see a better relationship. So the main graphs we are going to look at are scatter plots. So when we graph data, there are certain rules that I want you to follow. And these are my 7 rules for graphing any sort of data. The reason I want you to show these 7 rules is that we're always getting good results, is that we're always seeing the results we want to see, and so that when you are actually going about and actually finding a relationship, that when you have certain things labeled and with the proper units and all that, that we are getting relationships in a good way. So starting off, the first rule that we have is starting the origin at 0, 0. Okay, many times in math class, if you get data that starts far away from 0, say it starts at 750, what they teach you is to use something called a break. Okay, that's if, let's say it's on the x-axis, you get sort of a line like that, and then you start your data collection at some number, say 750. So what happens here is you're jumping all the way from 0 to a very large number, and you're skipping any value in between here, and then maybe your scale goes up by 50. Okay, the reason why in physics we're going to start at 0, 0 is because a break, you are really skipping the relationship between 0 and 750. What's going on between those two numbers? All right, physics are things that happen in real life. It's not math. Well, it is math, but it's things that are happening in real life. So we can't just ignore these numbers because maybe something's not going on between that number, but we just can't ignore it. We can't skip it. Okay, because these are real values. All right, the next thing with the graph. We talked about last lesson in a controlled experiment, you have 2 variables, the independent and the dependent. All right. Now, when we create a graphical model of those variables, we need to properly place them on the graph. Okay. Now, in math class, you're always taught that the x-axis should include the independent variable. All right. So the independent variable always goes on the x-axis. Remember, the independent variable is the variable that you change. Okay. We introduced the Galileo experiment in which we had mass, size, height. Those are our independent variables, so that variable is always going to go on the x-axis. Okay? The dependent variable, the one that is affected, goes on the y-axis. Okay? This is always the case. You will see some labs that we'll do in this class that we will actually graph them backwards, but I will tell you that and that we were going to do that for a reason. Okay? But all the time, your independent variable goes on the x, your dependent variable goes on the y. The next thing with a graph is you want to choose a constant scale. Okay? A scale is something like you see up here. Okay? Given your graph, given your data set, you're going to determine what your scale is going to be. maybe you see that your numbers vary from 0 to 20. Okay, so a good scale might be going by 2. So starting at 0 and going 2, 4, 6, 8, something like that. Up here my scale would be 50 because every next cell I'm going up 50 units. So my scale would be 50. So I'm choosing a constant scale on the x-axis. Now, the y-axis, you also want to choose this constant scale, but it does not have to be the same as the x-axis. You just have to make sure it's a constant scale. How to determine your scale, like I've already said, is to look at your data. If your data ranges from 0 to 20, choose an appropriate scale that fits your graph and fits your data. If your data goes from 0 to 1,000, well then choosing a scale like 100 would be a little more relevant than choosing a scale of 1. Okay, so choosing a scale that both represents your data and also fits your graph. With that constant scale, that's also showing that you cannot include any breaks. So you're not including breaks. Breaks are not acceptable in this class. Okay, then the next thing you want to do is label your axes with the proper quantity. Okay, so again, quantity is talking about length, mass, or time, so you're going to label whatever you're measuring, and then also including the units. So the units would be like, say, meters. Remember, we're always measuring in base units, so meters, kilograms, and seconds. So on our axis, we're showing what we are measuring and what are the units of measure. And then the last thing is to include a title. Okay, and your title is always written as y, your dependent, versus x. So y versus x. So if, for example, my dependent variable was, let's say, speed, and my independent variable was mass, then my graph would be titled speed versus mass. So always dependent versus independent. Okay, then the last two are somewhat confusing, but it's really helping us to show relationship. We're going to plot points. Now what we want to do with those points is actually put in a line or a curve that represents that data. We are trying to see a relationship. The best way we can see a relationship between variables is by looking at a line or a curve. So what you are going to do with your data is you are going to interpolate the data with a smooth line or curve. What that means, to interpolate data, if I have data, let's say, that looks like that, you can see that your data is increasing. So what I'm going to do is I'm going to fit that data with a line. This is also known as like the line of best fit. When using a computer program, this will be done for you, but when drawing by hand, you want to make sure that you kind of draw a line that represents your data. So looking at the first and the last point, interpolating means to go within your data and stay there and showing, okay, that's my relationship. If you look here, that line is not directly going by points. So I'm not going point by point by point. I'm not connecting the dots. But what it does is it shows the general relationship seen between these variables. Okay. Now the next one says you never extrapolate data. Okay. Extrapolating data means going outside. Extra means to go beyond. So you're going outside your data. Unless using a computer program, when you're drawing it by hand, you never extrapolate the data. Meaning, I'm not going to take this line and all of a sudden extend it to 0, 0, because I don't know if it's going to start at 0, 0. Maybe it starts with some y-intercept. Okay? Maybe it starts with some negative y-intercept. Maybe it's a curve, but I don't see the whole thing. Okay? So, you never extrapolate your data. You never go beyond what your data shows. All right? If you cannot determine a true relationship from your data, you either collected wrong data, or you didn't collect enough data. Okay, so you always want to find that relationship by interpolating but not extrapolating. And these are the 7 rules for graphing on what you're going to follow anytime you're graphing data. So here is an example of what a graph should look like. Okay, now obviously this is computer generated, but it's going to show you some of the things that you have. Alright, so first, notice it starts at 0, 0. Alright, I have my independent variable labeled on the x-axis, my dependent labeled on the y. I have a proper scale of you can tell the scale on the x-axis is 0.2, and on the y-axis is 1, so it goes 1, 2, 3, 4. Again, we're starting at 0, 0. I have a title on my graph of y, my independent variable, versus x. Okay. I plotted my points, and then notice within the points I have drawn, well, the computer has drawn a smooth curve that does not necessarily intersect the points, but it represents the data. And this graph or this curve is actually interpolating the data, meaning I'm not going beyond my two outside points. I'm staying within those 2 points and trying to determine a relationship from there. So I've interpolated, I have not extrapolated. So this graph shows all the 7 rules that we have in a proper way. So your graph, whether drawn by hand or done by a computer, should always look like this, or shown all these things. Okay, so let's go through and do an example of graphing a data by hand showing all the 7 rules. Okay, so here I have a data table of time versus x, and showing the units we have time in seconds and x in meters. Okay, for now we will assume that the left column is our independent variable and the right column is our dependent variable. So time in seconds is going to be our independent variable, and x in meters will be our dependent variable. So first thing I'm going to do is I'm just going to start off by labeling my graph. Okay, so my x-axis is always on the bottom of the graph. So here's my x, here's my y. I'm going to label these with the actual quantities we have. So my x variable is x in meters, and I label it with both the symbol or whatever I'm measuring and the unit. So I'm including meters on there. Okay, and on the y I have time in seconds. Now I'm just including the letters because we're not given the words. We're not told it's time or x, so I'm just writing what I have in my data table. So I've labeled the x's. Putting a title on it, I could do that right away. You could wait till the end, but we are going dependent versus independent, so it's time or t in seconds versus x in meters. So the title is just showing what this graph is showing. Now actually plotting the points. We're going to start, first rule, start at 0, 0. It's going to show it like that. So I'm starting at the origin at 0, 0. Now I'm going to plot my points. Now before I plot my points, I need to choose a proper scale on both the x and the y. So looking at my x column, time in seconds, my independent variable, I have times that go from 0.1 all the way to 5. So what should my scale be? Well, if you look at some of your later points, it kind of gives away what's an easy scale to have. You go 1, 2, 3, 4, 5. So what I'm going to choose my scale to be is by ones. Okay? And on my graph, I'm going to choose a certain amount of boxes that are going to represent that. And I'm actually going to go, every 2 boxes is going to represent 1. So really my scale is not just 1, but it's actually 0.5, because I'm going 0.5 to 1. And in every 2 boxes, I'm going to go up by 1. Okay? So there's my scale on the x-axis. Do the same on the y. Look at my data. I go from 0.03 all the way up to 75. Now you're going from a small number to a relatively big number. So this one's a little more difficult. But again, looking at your later data, you go 3, 12, 27, 48, 75. So I'm going to choose a scale of 5. So starting off with my first box, I'm going to go 5, 10, and I'm just going to kind of skip a few to just make this go quicker. 10, 20, 30, 40, 50, that's a 5, 60, 70, oops, and then this last one up here would be 75. Okay, so the scale fits my data, and it's a constant scale of 5 all the way up and through. Okay, now once I have my scale, now I can actually plot the points. So I'm going to go ahead here and plot the points. So the first point, x and y, I have 0.1 and 0.03. So my time is 0.1, which is going to be somewhere there. So this point is almost going to be at 0, 0. On this scale, it's kind of difficult to see, but it's about 0, 0. Then I go 0.2 and 0.12. So that's going to move over a little bit, and it's also going to move up a little bit. Then I go 0.5 and 0.75. So 0.5, 0.75. 0.5 is right in the line. 0.75 is up a little bit. Then I'm going to go to 1 and 3. So now we're moving up more. Then 2 and 12. Okay. Then we got 3 and 27. 4 and 48. So I follow 4 all the way up to 48. And lastly, 5 and 75. So that's going to be up there. Okay, so I plotted my points. And now the last thing is to interpolate the data. Okay, I'm going to interpolate this with a green line. Okay, so I want to start looking at my data. I start down here almost by the origin. Okay, and my last data point's all the way up here. Now, the first couple points look almost like it's a line that's going to look this, but now you can see that it's starting to curve up and expand a lot more. So as you follow this kind of laser pointer, you can see that I have a curve here. So I'm going to interpolate the line the best I can with a curve. So starting down here at my first point, I'm going to follow this up and through and interpolate the best I can all the way up there with my curve. And this is a proper way to graph the data. So I again followed my 7 rules, started at 0, 0, labeled my x and y axes with the proper variables and units. I chose constant scales in the x and y, and interpolated my data, included the title, and all that jazz. Okay, this is a pretty darn looking graph. Alright, so now you know the 7 rules of graphing. You're going to start by graphing by hand, and when we get onto the computer simulations, you'll actually see how these 7 rules will still apply.